is C?
It's like a counter.
It's an integer?
Yeah.
Okay, so count's a two-dimensional array. So you need two indexes on it. So your count, okay, so yeah, let's spec this out on paper, because this is a recurring theme. So we have a dictionary of words, right? And your words are characters. And we've said we can limit ourselves to 1,000 phrases, 200 characters each word, and then one extra spot for the null terminator. So we can do a char 1201. You also need to know how often each phrase has occurred. That's a one-dimensional array of integers that we could think of as count, right? Or phrase count, or phrase number of occurrences, or something like that. And we also need to know how many things actually are being used in this array, so we need one more integer, like dictionary length. Which we can initialize to 0. So the setup here is if we have dictionary bracket I, what is that? That is a string of 201 characters, right? It's no different from if we said something like character phrase bracket 201, right? This is exactly the same kind of thing as phrase, right? It's an array of 201 characters. It's one element of this two-dimensional array. So this is a string. We can use it in string length, we can use it in string copy, we can use it in printf. And the corresponding element I of the count array, that's an integer, that's how many times that string, that phrase appeared in our input. So those two things go together. And dictionary length tells us, what's the biggest value for I that's meaningful here. So if we have 10 phrases stored, dictionary length will be 10. We can look at dictionary 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the corresponding count 0 through 9 goes with that phrase. And so let's look at some code. Missing comments, but imagine there's comments up there. So let's do something simpler than PA4, because I don't want to take away all your fun. But let's do a simplified version of this. So let's just loop 5 times. Okay, this is not PA4. Don't try to do this in PA4 and come back to me Thursday night and say, I'm doing what you did in class and it's not working. This is not PA4. This is just a way to throw some values into the first 5 dictionary entry spots. Okay, so this is how we could declare our dictionary array and our count array and set up a dictionary length. But this stuff is all totally fictitious. Okay. It's not related to PA4 directly. So what we're doing in this junk code is we're just looping 5 times, and we're asking the person to type in a phrase, and we're just going to store it in this ith entry in our dictionary. Okay, just to show that we can store things in there and it works just like a plain old string. I'm going to set dictionary length equal to 5. And dictionary is our list, and let's print our dictionary. So we're going to read 5 phrases from standard in. We're going to write them into the dictionary because we're using that as the string that we're storing things in fgets, right? So dictionary bracket I is a string of 201 characters. And then I want to make this print dictionary function that's just going to print out the first 5 entries in the dictionary, just to sort of see passing things to and from a function. So So let me prototype this. Okay, so print dictionary takes a character array and an integer. Here's our print dictionary. Alright, there's a print dictionary function. So it takes an array which is also 1000 by 201 characters, and I'm going to loop through whatever that second argument is, and I'm just going to print out with a %s that dictionary argument bracket I. Again, d bracket I is a string. It's a character array of 201 characters. So if I was just passing, you know, a chars temp bracket 201, right, down here I could say character d bracket 201, and down here I could just print out d, right? Well, exactly the same thing, except this is an array of such strings, where each string is 201. And so, other than Friday morning typos, this should work. Let's see what happens. So that's just illustrating how we can use this two-dimensional array really just as an array of strings, and how each element of this array is really just a char star, right, or a character bracket 201. Now you need to do something different in PA4, right? You need to use your getChar function and pull in characters and build up phrases. But once you have a phrase, you've discovered this is a phrase, right? We can copy it into an entry of our dictionary as follows. So here's our temporary string that contains our next phrase. So let's fgets. May as well do 201. Let's just use fgets to get our next phrase instead of calling our phrase builder. And if we want to copy that into our dictionary, you can use string copy. So string copy takes two arguments, the thing you're copying to and the thing you're copying from. So this should copy next phrase into the ith entry of our dictionary, which again is a character 201. So what's the lesson here, right? You already know how to do this. The syntax is different because it's a two-dimensional array. But if you just think of, yeah, dictionary is a two-dimensional array, but as soon as I say dictionary bracket something, that's just a string. It's just like character temp bracket 200. And everything you've done with strings, string length and printf and that sort of stuff is exactly the same. And you just kind of have to believe that since this is d bracket 1201, when I say d bracket I, that's a character bracket 201. And I know that's a string, and I know I can use %s to print that, or string copy to copy it, and so on and so forth. But it's really important that every time that I'm using my dictionary, I'm setting it up as a character 1201. That's different from a char star star. We may play with that later on today, if not today, then Tuesday. But a char star star is different fundamentally from a character bracket something, bracket something. They're stored differently in memory. Char star star is more general, but I've given you the permission to hardwire these dimensions on this array. Assume your dictionary is always 1000 by 201, and it lets you just use this declaration everywhere that you touch your dictionary. And it lets you hardwire things. Like if you're building a phrase, you know it's only got to hold 200 characters plus a null terminator, so I can just make my temporaries 201, or maybe 210 if I want to have some wiggle room. All right, does this look reasonable? All right, questions on this related stuff? So let's talk about how we actually make phrases. So we've got this perhaps convoluted description of how phrases begin and end. Phrase begins with a non-space character other than magic. It's a collection of consecutive characters excluding magic, and it ends with magic. So let's flowchart this. So this is how we read a phrase. So C equals the next character from our input stream. And this is super duper get char. So we know it's uppercase. If it's a white space, it's a space. It's not something we're supposed to ignore. Could be end of file also, right? So so read a character, and we've always got to see if we've had end of file. If we have, we can just return. If we're not at end of file, what do we do? Well, when we begin, we don't have a phrase yet. When you first start doing this, We're waiting for a phrase to start. So how do we know that the phrase has begun with something? Well, it's got to be a non-space character other than one of these magic characters. Okay, so is C equal to a space, a dot, a comma, a colon, a semicolon, exclamation mark, or a question mark? If it is, we haven't found the beginning of a phrase yet. So we need to go back and we need to get another character. So my comment on this section might be something like, looking for start of a phrase. All right, get a character. If it's end of file, just return, we're done. If it's equal to a space or a period, comma, colon, semicolon, exclamation mark, or question mark, go back up, get another character. So we're going to sit here in this loop until we find something which begins a phrase, which is anything that's not one of these and not a space. Okay, so now when we come out of that loop, we're at the beginning of a phrase. So we're looking for letters, characters, spaces, anything except one of these magic characters. And as we read these characters that are part of our phrase, we need to save these in some kind of temporary string. So that when we're done with this and we hit the end of the phrase, we have a string which says, this is my phrase. So let's do our usual trick. Let's keep track of where we want to save things in our output array. So we'll have an output location and initialize it to 0. And we'll get a character. And again, we'll check for end of file. And if it is, let's just return. Return something that says we hit end of file. I don't know, return 0. All right, if we read a character and it's not the end of file, is this one of these things that terminates our phrase? Okay, if it's not, then what do we do? Save it in our output array. And then go back up and get another character. So let me move this down. Okay, read a character. If it's not terminating a phrase, just save that character in our output array, bump up the output location, go back up to the top. If it is the end of a phrase, well, we need to throw a null terminator on our output array. And outloc is always the location where the next thing should be stored in this output array. So if you work through some test cases, you can convince yourself this is probably the right thing to do. Just throw on a null terminator at location outloc. And then let's just return 1. We'll take the return value from this to say 0 means we hit end of file, One means we found the end of a phrase, and that phrase is stored in this output variable. So you might write this as a read phrase that you pass it a character array, right, which we're going to call out inside here, and this is going to populate that character array with the next phrase. And then this function will return a flag which says, did I actually load a phrase in, or did I hit the end of the file? So in my main program, right, this would be while read phrase returns 1, right, take the phrase that it returned and copy that into the next spot in my dictionary, bump up the counter, right, or something like that. Yeah.
So at the beginning you said C equals that char.
Mm-hmm.
And then after the count notation equals 0, you do the C equals that char again.
Mm-hmm.
So it's the first that char ends at the letter, then it will go down.
Yeah, this is the no. Oh, you're right. This get car should go at the bottom. Okay, good. There's a bug. So if it's not a letter, we need to do one other thing in here, which is out bracket output location plus plus. Right. So the first time we read something and it's not one of these characters, we found the beginning of our phrase, we have to store that in our output array. Right, that's the first character of the phrase. So we save that, we bump up outlook, and then we go into this loop to keep reading characters. Each character we read, we will store in the output array, and we keep doing this until we get a magic character which ends our phrase. We add the null terminator and we return at that point. Yeah.
This is just general.
Mhm.
So when you say outlook plus plus, it takes the outlook as 0 and then saves it at 0 and then increments it. Right?
Exactly, yeah.
If you do plus plus, it'll increment it and then save it at the incremented place.
Correct,
Okay.
exactly. Yeah, so this is called post increment, and the alternative, putting in the plus, is pre-increment. And those are the names of those SFRs in 270. Yeah.
Can you define conditions using the define statement? Because it'd be really nice to say while, like while start condition or something,
Mm-hmm.
right? So
Absolutely.
Okay, so you use like before statements and stuff.
So yeah, so this is a big long if statement, right? So there's a few alternatives. Well, a typical alternative would be to make a function, right? So integer is magic character C. So write a function that takes a character, and if it's equal to a period, comma, colon, semicolon, exclamation mark, question mark, returns a 1, otherwise it returns a 0. And then this block up here looks something like this. If C equals space or is magic C, then we want to go back up to the top. And this test down here is just if is magic C. Then set a null terminator, and right. Or if you want to do this as your no and this is your yes, right? If exclamation mark is magic, if not is magic. Same thing. So that saves you from having to write this big long 6 or 7 part if statement again and again. Or you could make it define. that basically bundles all of that together. All right, that's basically your phrase builder. That's really the guts of PA4. You have your super duper get char at least in mind, which is handling the uppercase and white space and all that sort of stuff. And the main heart of PA4 is let's read a phrase, right? And then we have to store it in the dictionary and so on and so forth. But reading the phrase is probably the trickiest part. And that's really all there is to it. And this is really just a kind of strict interpretation of this definition of a phrase. Right? It begins with a non-space, non-magic character, so let's loop, and if we have a space or a magic character, let's loop again. Keep reading characters. Right? Once we fail that test, we know that we have the beginning of a phrase, save that in our output array. And then we want to take whatever comes after that until we find something magic. That's what builds up our phrase. So keep reading characters, and if it's not magic, store it in your output and keep going. And then when you encounter a magic, that's the end of the phrase. So that's when we throw the null terminator on. So different ways you can do this, but there's an idea of a flowchart for it. And these things are fairly straightforward to code into C, right? This is called the super duper get char. If C equals EOF, just return 0. That's pretty straightforward. How do we loop repeatedly? Well, we need some kind of while loop around this, and so we could get a character first and we could say while C is equal to one of these things, do get a character, go back up to the top. When you come out of the while loop, check for EOF. If it's not EOF, go down here and continue. But if you have something like this in mind, right, and you can break this into pieces, right? You can just work on this part that finds the beginning of a phrase, right? Make a flowchart for it and then write some code. And like I say, I would suggest maybe something like integer read phrase character phrase bracket 201. And so in your main program, have some temporary array with 201, and you could have integer status equals read phrase, and pass it the argument p. And when this returns, status should be 0 or 1. If it's 1, then p should be a string that contains your first phrase. And if you call this again and it returns a 1, p should be your second phrase. Well, now that's really easy to test in the main program, right? Your main program is just while read phrase returns 1, let's just print out what the value of p is. Throw it inside angle brackets, throw some extra spaces at the end so you can clearly delimit it, and feed that a set of text, and you should get phrases coming out one at a time. Nice uppercase, pre-processed, all that kind of stuff. And so building your phrase reader is a good piece to work on, kind of in isolation of the other details. Super duper get char is a piece maybe to do first, or you could do it later. You could say, I'm not really worried about super duper get char yet, and forget about uppercase, lowercase, special characters, white space, and so on. Just, work on this part. And know that later you'll replace your get char with call to your version of get char. One of the real tricks for this is being able to break the problem down into smaller pieces. And it's not really important what those pieces are within reason. They can be whatever pieces you decide you want to break this thing down into and work on. But pick a piece that you think you can make some progress on, that you can get past the dreaded empty screen with the blinking cursor staring at you, right? And start writing some code for some part of it. And once you have some code, get it to compile, get rid of the syntax errors, and then start running it. Feed it different inputs and see what it's doing, and let that be the process by which you decide if it's right or if it's wrong, what's going wrong, and build it up. It's usually easier to add things to something that's already there. And then we can worry about more details. For example, what if your phrase is longer than 201 characters? As we've written this is going to do bad things, because there's nothing that stops outlocation from getting bigger than 200. And if outlocation hits 201, then we're writing into the 202nd element of an array that only holds 201 things. So you need to do something in here to see if your output phrase is too long. And maybe, before you do this, make sure that output location is not too big. So we know that output location, when it's 200, that's where we want to store the null terminator. So maybe in here we could say, is output location less than 199? And if it is, we can go ahead and do this. Otherwise, don't do this. And the effect will be that once we get to that 200th character that's been stored in our output, right? If we find more characters, we're just not going to store them. We're still going to do all of this. We're still going to look for the end of the phrase. But when we find something which would be part of the phrase, we basically ignore it, which is exactly what you want to do. So if it's a big, long run-on sentence, you store the first 200 characters. And if you find a 201st character, don't save it. If you find another one, don't save it. And then when we find the end of the phrase, we'll store this in the 201st position. There's the null terminator at the end. We got 200 characters in the phrase. So there's stuff you have to add to this, but like I say, as a starting point, that's a good first order. It's actually a fairly complete solution. So questions about this? All right, so what do we do when we've read a phrase? We called our read phrase and it returned a 1, so we have a new phrase. For your test code, like I say, I would just print that out, go back, get another phrase, run that, and make sure it's reading phrases correctly. But when we're actually writing the rest of PA4, what do we want to do once we have a phrase?
Do you want us to sort it as we're building it, or do you want us to sort it after?
I would sort it out. You can do it either way.
Okay.
If you're just going to do a straight bubble sort, you could just do one call to your bubble sort at the end.
Okay.
But if you want to do it as you're going, that doesn't do any harm.
Okay.
So you can imagine a function maybe like save phrase that takes two arguments, a dictionary and the phrase that you want to actually save. And you probably also need the dictionary length. Because the dictionary is just a big array of 1,000 spots, but we don't know how many of those spots actually have phrases. So you have to tell it the dictionary and the dictionary length, and then you have to tell it what phrase to store. So we want to know if the phrase is already in the dictionary. And if it is, let's see, we also need to pass in our array of how many times each phrase occurs. So you have to pass the dictionary, you have to pass the count of how many times each phrase occurs, you have to pass the length of those arrays, and then the phrase you're storing. So if the phrase is already in the dictionary, we have to increment something in our count array, right, where I is where that phrase is stored. So assuming our phrase was found at dictionary position I, we bump up count bracket I, and we return. If the phrase is not in the dictionary, well, dictionary length is the number of things in the phrase. When you have arrays, if we have 3 things stored in our array, dictionary length is equal to 3. Dictionary length tells us where the next phrase should be stored. Okay, this is just how arrays work when you start indexing from 0. If you know how many things are currently in the array, that value tells you the index where you should store the next thing. So when we start off, dictionary length is 0, that tells us the first phrase we find gets stored at location 0. If length is 3, we've got things in these 2 spots. The next phrase would go into the 4th location, which is index 3. So all you need here is string copy, dictionary bracket, dictionary length, comma phrase. So dictionary bracket, dictionary length is the next location that's available. And just copy your phrase into that spot. And then count bracket, dictionary length. Set that to 1 to say we've seen this phrase 1 time. And then increment dictionary length. And then return. So copy the phrase into dictionary bracket, dictionary length. Copy the new count, which is 1, into count bracket, dictionary length. And then increment dictionary length. That stores a new phrase into the dictionary. If the phrase was already found in the dictionary, assuming it was found at position I, just increment count bracket I. Don't change the length because it's not a new phrase. Don't copy your phrase because it's already in there. And so how do we tell if the phrase is in the dictionary? So here's a dictionary, here's a phrase. What are you going to do to tell if that phrase is in there? Say again? String compare. Okay, what do we compare with? Yeah, everything in the dictionary. So make a for loop for I equals 0, I less than dictionary length I plus plus. If 0 equals string compare, dictionary bracket I, comma phrase, you found the phrase. Where is it? It's at position I. If you go all the way through that loop and you haven't satisfied that if condition, then you know it's a new phrase. And so you go ahead and you add it to the end of the dictionary. So this is, a 1-page flow chart with, 3 blocks on it. There's a lot going on in here. But we can think of it in terms of these very high-level blocks. Is the phrase in the dictionary? Well, that's a loop and a string compare and all kinds of stuff. But functionally, it's just, search in the dictionary for the phrase. And if you find it at position I, bump up the count. If you don't, then copy the new phrase to the end of the dictionary, set its count to 1, and bump up the length. So this is something that you want to try to get your brain around, what this is doing, right, or the equivalent of this that you come up with. And you don't have to worry about anything else in PA4, right? You could just work on this piece by itself. And you could just enter a phrase with fgets and build up a dictionary of phrases that you type in at the keyboard. And it will search the dictionary and bump up a count. And you could just do this, 10 times and then print out your dictionary and counts and see if this part's working. It's another piece you can develop in isolation. And is phrase in dictionary, you could make that a function. And you could call it is phrase in dictionary. You pass the dictionary, you pass it the dictionary length, and you pass it the phrase, and it gives you back a 1 or a 0. Or it gives you back a 0 if it's not found, or maybe you could give back a -1 if it's not found, and if it is found, pass back this value I where you found it. Right, so now this is if is phrase in dictionary equals -1, then do this. Otherwise, take the value at return, that's I, bump up that count. So this is getting into the mindset of also thinking about your functions in terms of how you're going to use them, right? I want a function that tells me if my phrase is in my dictionary. What does it need? It needs the dictionary and the phrase. What do I want back from that? I want to know if it's in the dictionary or not, and if it is, I want to know where in the dictionary it found that phrase. So now I've got an idea what's going into this function, what's coming out of it, right? My system diagram in 120. And so that affects, what arguments I pass to it, what the return value is going to look like, and so on and so forth. And, this is a function you can write and just test on your own. You can populate your dictionary by doing something like this, and then just grab a phrase and call your is phrase in dictionary functions, make sure it's doing the right thing. Once you've got this in a nice little function, now it's a few lines here and 1 line here, and you use that function to decide which way to go. So again, building up, right? Playing Minecraft. Put the pieces together in a way that works for you, but you get to decide what the pieces are. Questions?
Is there any standard or a best practice for when we should put functions into like your main file or coupled with another function versus them getting their own file? Or is it always just best to do them separately?
For now, I would say do what kind of makes the most sense to you, but be open to trying different ways. If you put every single function in a separate file, it can get a little out of control, right? And if the only time I'm going to use this function is inside this save phrase, bigger function, I would probably put that in the same file. So I would have a file called save phrase, and it's self-contained. It might have multiple functions in there, right? But it's still kind of a bite-sized piece. But find a balance that feels right to you, right? And if you do all this in one file, that's perfectly fine. You're not going to lose points for that, okay? But eventually you're going to be working on projects that you really, really need to break up in different pieces. So you just want to kind of start exploring that. And this one has some fairly clean boundaries that you can play with. So, but I don't know what best practice is. It probably depends who you're working for and what they had for lunch that day when they made the rules. All right, so hopefully this gives you a start, and I'm not trying to give you the impression that this is easy just because I wrote it up on a piece of paper, okay, and it's only a few blocks. This is the most challenging thing in programming, right, is coming up with an algorithm and being able to think of it in terms of, okay, how am I going to turn this into code? That's the essence of programming. That's the challenge that most of us in this course are struggling with throughout the course, right? But I want you to come away with the impression that this should be where you are feeling the struggle, where you're being challenged, right? And if this is easy for you, okay, it'll be an easy ride for the rest of the course. In 222, there'll be some new things to learn. But if this is feeling like a big challenge to you, that's good. That's where you want to be, right? The thing I'm trying to do is give you some techniques, some tools to keep breaking things down into smaller pieces, right? So that we can eventually get to a level where the pieces are small enough that we can sit down with the blank editor window and we can actually write some code that will do, you know, this or that or maybe that, and eventually this, and eventually, you know, PA4. So let me know if you're feeling kind of, you know, lost how to go forward from here. I was going to talk about sort of bigger steps for PA4, but we're out of time right now. But we can talk more on Discord or an email or on Tuesday about sort of how to practically use this to make progress on PA4. All right, so I will see you next time.